Oh, that was scary, wasn't it? Hey, speaking of scary, we got a new lesson here for you. And I hope you've got those notes out and you're ready to go. So, no more waiting. We're around page 265. And hopefully, you've got the pencil, paper, all that stuff, and you're ready to go. I'll shrink my head down. Some of you have asked what I look like, for those of you who don't know me, and this is probably the closest that we've come. All right, so let's talk about greatest common factor. Now, you're going to just have to trust me. Some of you are going to pick up on this pretty quickly, but there's a reason why we're in Algebra 2 in summer schools, so I'm going to need you to trust me and try doing this my way, even if it's not the same way that you've done it in the past. Doing it my way is going to take a little bit of writing on your part, but it's going to be so much less difficult on your brain. Basically, you're just going to be looking for things that match and circling them and then writing the answer down. So, super easy, right? All right, let's get started here. We're going to do something called a factor tree. You've probably done factor trees in the past in middle school. So all you have to do is try to come up with two numbers that multiply together that equal 9. You're not allowed to use 1. All right? So 9. What times what is 9? That's right! 3 by 3. So 3 times 3. Then, once you have each of these numbers, you're going to try to find something that divides into that number, not 1. All right? Can I multiply anything to make it 3 other than 1? No. So I'm done. That's all I can do with that one. We'll worry about the x cubed in just a moment. So 21 is what times what? I can't hear you. That's right, 3 and 7. Great job. So I put 3 times 7 right there. Again, we'll worry about the x to the 5th in just a moment. So my next goal is to circle whatever they both have in common. So looking up here, what do they have in common? Well, they each have a 3. So I'm going to circle 1 3 from each of those, and then I'm going to write it down. Just like that. Pretty simple, right? Okay, now I have x cubed and x to the 5th. Let's think about this. We're looking for what they each have in common. So there's that one. Here's the x to the 5th. They're all touching because they're multiplied. All right, and we're seeing what do they all have in common. So let's circle what they have in common. There's an x. There's another x, and there's another x. So they have x times x times x in common. So instead of writing out x times x times x, I could just write x to the 3rd power. That's it. My GCF is 3x to the 3rd power. Now, it was only a coincidence that those were both 3's. That doesn't normally happen that way. All right, so you're probably wondering, well, what would be an easier way to do this without writing it all out? I'm glad you asked. Let me tell you. So instead of writing it all out, so for example, if I had 21x to the 500th power, I wouldn't want to write out 500 x's. That would take forever. So instead, what I'm going to do is I'm just going to look at my two exponents. Whichever one is the smallest exponent is the one that will run out of x's first. And that will end up being my answer. So in this case, my exponents were 5 and 3. Since 3 is the smallest, I picked 3 for my exponent. So whatever the smallest exponent is, that's what you write here for your GCF. So 3x cubed is my GCF. Smallest exponent there, and then whatever they have in common goes in front. Let's try some more. This time I'm making these a little bit longer, so this time instead of just having 2 terms, I have 3. Just like before, I'm going to think of what times what equals 8. Now, 8 is a special one. We use 8 so frequently that I do something special with 8. This is the only one I do it with, but I make 3 prongs instead of just 2. So 8 is the same as 2 by 2 by 2. Now, if you want to, you could do 4 times 2, and then 4 would become 2 times 2. It's the same thing. So remember, 8 is 2 by 2 by 2. Now 16, let's do 16. My advice to you is whenever you have double-digit numbers or bigger, you're going to want to pick numbers that are close together. So your options could be 2 times 8 or 4 times 4 for this one. My advice would be take the ones closest together because it will make your life easier in the long run. If you pick 2 numbers that are far apart, it will often mean more work for you. So I'm trying to make the work as little as possible so pick numbers that are close together. 2 times 2 is 4, and like we just said, 2 times 2 is 4. Then over here I've got 12. You could have chosen 2 times 6 or 3 times 4. I always pick the ones close together, so I do 3 times 4. Now 3 does not reduce, but the 4 does, so I'm going to bring the 3 straight down. Don't forget to bring it down. If you forget to bring it down, that's going to mess you up later on. You'll just have to believe me and trust me for right now. That 3 down here will be very important. 4 is going to be 2 times 2. Alright, so we've got 2 by 2 by 2 is 8. If you want to check your answer, you could just type this into the calculator really quickly. 2 times 2 times 2, 8. 2 by 2 by 2 by 2, 16. 3 by 2 by 2 is 12. There, we know we're right. Now, if I asked you what's the GCF of that, you are going to take whatever they have in common. So in this case, well, we have a 2 here and here and here. Do they have anything else in common? That's right, another 2. So I'm going to circle a 2 and a 2 and a 2. Oh, I forgot to write them down. So there's 1, 2, there's another 2. Do they have anything else in common? I didn't hear anything. That's because they don't have anything else in common. Great job. So this has a 2, this has 2's, but that one does not. This has a 3, but those do not. So they have nothing else in common. All I have is 2 by 2. So that would give me 4 if I multiplied them together. So since 2 times 2 is 4, 4 is the number part of my GCF. Now let's think about my variable part. So looking at my exponents, 4, 3, and 2, which one would I choose for my GCF there? You chose 2! Great job! 2 is the smallest exponent, so that's why we used that here. They all have 2 x's at least in common. Alright, now that we've done this a couple times, you go ahead, try this one, hit pause, try it, and then come back. Did you do it? Oh, I hope so. Good. Alright, so let's do this. Here we go. Alright. 8. 8's the special one, remember. I make that 2 by 2 by 2. 22, my options here are only 2 and 11. 16. We already did 16 right here, so hopefully you got that one right. And we had done 8 already, so really the only new number you were doing was 22. This is 2 by 2 by 2 by 2, just like this one. Great. Now, what do these have in common? Well, hopefully you circled a 2 for all of those. Is there any other number that they have in common? That has a 2. That has a 2. This does not. That has an 11, but those do not. So 2 is the only number that they have in common. Now let's talk about our x's. How many x's do we have for our smallest exponent? I believe I tricked you. Let's find out. So this has a 3, that has a 2, but this has no exponent. How many exponents? None. Also known as 0. So you should put nothing there because this had nothing. I'll just get rid of that just to remind you there was nothing there. So I should put nothing here. So my GCF is just 2 because they did not all have an x in common. This term does not have an x at all. Alright, that was a tricky one. Alright, now we're going to do something called factoring out the GCF. Oh, I was supposed to factor out the GCF here according to my directions. I didn't mean to put that. I just meant to find the GCF. Sorry about that. My directions were messed up. So this should say find the GCF, not factor out. Let's just scratch that out and write find. Sorry, I copied and pasted. It happens. Okay, so this time I'm going to factor out the GCF. So what I'm going to do is the first thing that I just taught you. I've got 18, which is 3 by 6. 3 does not reduce, but 6 is 3 times 2. Just like that. Now we're going to do 12. 12 is 3 times 4. 3 does not reduce, but 4 does. Alright, super easy. Let's figure out what they both have in common. There's a 3, There's a 3. So I'm going to write down 3. And there's a 2. And there's a 2. So I write down 2. This has a 3, that has a 2, so they have nothing else in common. Now I'm going to look at my smallest exponent, which was 2. So 3 by 2, x squared. 3 by 2 is 6. So this is the same as 6x squared. Pretty easy so far. All right, that is my GCF. Now when we're talking about factoring out the GCF, remember factoring means we're going to have a set of parentheses here. To factor out that GCF, I'm going to actually do some dividing. So I'm going to move this over so we can see what's happening here. So factoring out means I'm going to divide each of these terms by that 6x squared. What I'm really doing is I'm doing distribution, but backwards. Instead of multiplying something into the parentheses, I'm sucking something out of the parentheses and putting it to the outside. I'm taking out what they both have in common. All right, I'm going to erase this 3 times 2 to the x squared just so it's not in the way. All right, so both of these are going to get divided by 6x squared. Now, if you did well during the exponents unit, this should help you greatly. 18 divided by 6 gives me 3. Put my minus sign there. 12 divided by 6 gives me 2. Now I should subtract the exponents. So I've got 3 minus 2 gives me 1. If you want to write the 1 there, that's fine. If you don't, that's okay. 2 minus 2 gives me 0, so I do not write an x here. In fact, if you're taking out the GCF, if you ever have an x for all of the terms inside the factor, you screwed up. They will never, ever have anything in common, these things inside the factor. All right, that's a great way to check to make sure you're doing something right. So if both of these ever have an x, you know you screwed up. All right, that's it. We have just factored out the GCF. All right, I'm going to give you a shot to go ahead and try this one. Go ahead, find the GCF, and then come back before you factor it out. All right, looks like you got this. So 32, hopefully you did not choose 2 and 16 because those numbers are too far apart. 4 times 8 would work. I know that 4 is 2 by 2, and I know that 8 is 2, 2, and 2. That's a times sign, sorry about that. Then over here, 24. You could have done 2 and 12, but that's going to make your life more difficult. Hopefully you picked 4 by 6. 4 is 2 by 2, and 6 is 2 by 3. Okay with that? Fantastic. Now I'm going to circle whatever they have in common. There's a 2, so I'm going to write 2. There's another 2, so I'm going to write another 2. There's another 2, so I'm going to write another 2 still. This has 2's, that has a 3, nothing else in common, so I know 2 by 2 by 2 gives me 8. So my GCF is going to be 8. Now I have to look at my exponents. This has a 2, this has a 1. So hopefully you put x to the first power. That's your GCF. All right, now that I did that, you go ahead, divide 8x to the first power into each of these to figure out what is left. Go ahead, hit pause, and then come back. All right, so again, I just brought this over here so that you can see it easier. I'm going to take those and I'm going to divide each one by 8x to the first power. All right, let's try dividing. I'm going to put parentheses because that's the whole point of factoring. 32 divided by 8 is 4, and 24 divided by 8 is 3. Notice that I always, just like in exponents, always do the big numbers first, then go back and do the exponents. It's so much easier on your brain that way, and, you know, why hurt your brain? So I've got 2 minus 1, that gives me 1. 1 minus 1, those cancel, and I don't write anything else here. Remember, if you have an x in both of those, you screwed up. And that's all there is to it. Now, if you wanted to check your answer, it's so easy to do. Let me show you how. So you know how to distribute, right? Yeah. So I could distribute that into both of these. So 8 by 4 gives me 32. 8 times negative 3 is negative 24. 1 plus 1 gives me 2. And 1 plus nothing gives me 1. And look, that's what we started off with. All right, that's, again, just a way to check your answer to make sure you're doing it right. This right here really is the final answer. All right. Okay. Now, the last time there were no equal signs at all. This time we have an equal sign. We're going to solve this equation by factoring out the GCF. Fortunately, we've already done this. You just don't realize it yet. We're going to put together a bunch of different things that we've already learned. So let's do the GCF just like normal. Go ahead, hit pause, do the GCF, and in fact factor out the GCF, and then come back. Really? Really? You should do this now. Please. Please do it. Okay, now you've done it. Thanks for listening. So we've got 10 is 2 by 5. We've got 25 is 5 by 5. What do they have in common? There's a 5 there and a 5 there. So they both have a 5 in common. Looking at the smallest exponent, hopefully you put 1. So that is my GCF 5x to the first power. Now I'll put GCF there. And I'm just going to take this and copy it again. I hope that's okay. Let's see. Okay, I'm just copying again just to make room and have this look kind of pretty. All right, so I'm going to divide each of these by 5x to the first power. I put parentheses here because that's what factoring is. And then divide. 5 divided by 10, or 10 divided by 5, sorry, is 2. 25 over 5 gives me 5. Subtract the exponents, that gives me 1. Subtract the exponents, boom, they cancel. So now I have this. Those do not have any x's in common, so I know that I probably have this correct. Now, this says we're solving. So the difference here is that we have equals 0. Now, you remember from way back, not too long ago, that we played kind of like Wheel of Fortune, where the thing here and the thing here were like the boxes in Wheel of Fortune, and we know that each of those could equal 0, so that the whole answer equaled 0. So I'm going to set the 5x to the first power equal to 0, and then I'm going to set the other box equal to 0, 2x minus 5 equals 0. Then simply solve each one. So here I have to divide by 5 because 5 is touching the x, and that's just gross. 0 divided by 5 is 0. Then over here I'm going to add 5 to both sides and divide by 2. And that's all there is to that one. Oop, my shoulder's in the way. Sorry about that. 5 over 2 is the other answer. And that's all there is to it. If you wanted to check to see that your answers were right, you could put a 0 here for x and x in the original, and it would equal 0. And then you could put 5 over 2 in for both of these x's in the calculator, hit equals, and it will also equal 0. Remember, if you've got that $12 calculator from Walmart or Target or whatever, that $12 calculator will get you this check answer very quickly, and it's an easy way to know that you've done it correctly, especially on, let's say, a final exam in a little while here. All right, I'm going to let you try this one. Hit pause and then come back. All right, I'm so glad you did that. Good job. So here I've got 9 is 3 by 3, 6 is 2 by 3. Then what do they have in common? They have a 3 in common. What's the smallest exponent? Hopefully you put 1. Since there is no exponent there, I can write a 1. All right, again, I'm going to take this and copy it and just move it over. Just like this, just to make some more room. There we go. So they're all going to be divided by 3x to the first power. I'm going to put that on the outside. Don't forget to put whatever your GCF is on the outside. A lot of people forget that, so don't forget that. And notice it was equal to 0, so I copied that down. 9 divided by 3 gives me 3. 6 divided by 3 gives me 2. Subtract those exponents. This gives me a squared. This 1 minus 1 cancels, and that's all I have. So over here I have 3x to the first power equals 0, and 3x squared minus 2 equals 0. Super easy, right? All right, next I'm going to divide by 3. I get x equals 0. Boom, done. Now over here I'm going to add 2 to both sides. That square might be freaking you out, but that's okay. Then I'm going to divide by 3. I got x squared equals 2/3. Now normally we will continue on and do one more step with this, but we haven't learned that step yet. So for right now I'm going to let you just leave it as x squared equals 3/2. It's a super simple step. Oh, my shoulder's in the way again. Well, there you go, 2/3. X squared is 2/3. It's a super simple step, but for right now we're just going to leave it like that, and soon in the future you will learn how to do that even. All right, well, I think that's about all I have for today. So I hope you have had a great time. I hope you understood this pretty well, and if you have questions, you know where to find me. All right, everybody, have an awesome day. Get to that homework. Thank you.